Good morning, everybody. Unfortunately, I cannot show the structures because all of them, they belong to our customers and they are covered by the various NDAs. But I'll be very happy to talk about enabling them or about mass production of the cutting-edge microstructures. A few words about us, otherwise our marketing team would be very unhappy if I did not say this very important information. We've been founded 35 years ago, based in Marek, Switzerland. For the last 20 years in the same place, moved there from another location close by. We have a building of 2,800 square meters, about 300 meters of clean rooms with a different standards depending on the process. And we have pretty much about 40 specialized machines, which is more than people that work in our company. We are 20 few people, so it's a funny number that we have more machines than the people, but they are very specialized and we need a lot of time and training for these machines for people to operate. We have two words. One of them is micro and nanotechnology. The other one is plant building and security. My colleague, Marek, will give a talk about the plant building and security later, and now I will focus on the micro and nano applications and production. It all starts with the structure design. At the very left part, it's usually where some group of scientists develops a very, very difficult structure to manufacture, and something that will change the world probably, if we manage to produce it on a mass scale. I'm sure you all heard about Iron Shark. I think one of you also mentioned this yesterday. It's reducing the air drag, and you can significantly reduce, you can reduce the fuel consumption of 1 or 2%, which is actually a lot if you see how many flights are going on the long haul lanes. But you still have to produce the structures. You start with origination, with the lithography or any other method, then you have to go through the whole process of upscaling and making this actually on the foil or whatever else to bring it to life. So what we can offer you is a microfabrication with grayscale lithography. We can do it with a resolution of 300 nanometers, with the structures of the size up to 50 microns, and the size in X and Y about 220 times 220 millimeters. There is virtually no limitation in the shape. So there is some very small limitation, but I'm sure you're all well aware of the tapering rules and some rounding issues. The manufacturing process is very lengthy, time-consuming, requires a lot of specialized knowledge and equipment, and it's very expensive. What to do with this master later? To preserve it, one way is to electroform a nickel chip, to make a durable copy in nickel, in metal, that will serve later as a master for embossing or for copying or replicating. We have 5 custom built galvanic valves with this very big sizes, up to 1.5 by 1.7 meter. We are experienced in making shims ranging from microns to centimeters. It depends on the time, and the time of the valve can extend as much as you want, pretty much. You can make the blocks as big as a few centimeters, which can later be used directly for injection molding, for instance. The fidelity is extremely high, there's almost no structure changes, as long as it's demoldable. If you have undercuts or high roughness, you will not be able to demold and the structure will tear. As it was mentioned a few times, that's the one more thing I wanted to mention about the structure, about the preserving of the masters, is the very important shims family generations. So once you have the first shim, you can replicate, you can make a few generations of the shims and preserve the master and make as many copies as you want, or almost as many copies. It's always a lifetime of the shim, but you can make fairly cheap, fairly cost-effective, a few copies of the master from the very expensive origination that you've done at the early stage. But as we mentioned before, or as many people mentioned here before, this mastering process is very lengthy, long, and it requires a lot of specialized apparatus and people. And you cannot make it very large usually. Sometimes you can, but the prices are really, really extreme. So I think all of us are very happy about the step and capabilities. But at the times we already mentioned today, we have in-house developed self-made stepper repeat machine. It's called Google. It stands for High Precision UV Generation 1. It has two machine vision systems to provide the inspection on the go. It can upscale the master up to 1.5 and 1.3 meter. It has inline calibration system, so we can correct for rotation for the skew. As you know, for optical applications, skew can be detrimental. If you have a microlens skewed for a few argon seconds, so it can ruin the functionality. The accuracy in X and Y, it's ranging from 5 to 10 microns most of the time. And the axis itself, they are accurate for 1 micron, but this whole process that takes along. And usually we reach 5 to 10 microns accuracy. Can be less if the structure is very easy to upscale, to demote. If the structure is very stubborn and we cannot upscale this with the UV stepper repeat, we can make multiple shims and laser weld them together. We can also customize the shims and weld them and laser cut them for injection molding purposes. And one of the other mass scale production is making sleeves for roll-to-roll production. This is what you can also see in our stand, so you're most welcome to come and have a look on the sleeve. And it's a way to customize. So the nickel welding, you can put the shims together, you can weld them together, you can weld the multiple pieces together, and you can weld the shim from the top to start with a piece of metal to make it more stable for injection molding purposes. A few hard data of the laser welding system. The laser weld is about 200 microns wide, it's ranging from 180 to 200, and it has a profile of about 10 microns. It's the way it is, you can see there, but not really see the this is probably the most important slide. It summarizes all the steps here. So we always start with something that's very small. In this case, we have a Fresnel lens that was originated by diamond turning. We make nickel shims from this, nickel shims family, then replicate it to a sleeve or any other thing that will be able to help us with the mass scale application. In this case, it was a sleeve that was used for a roll-to-roll replication where we can produce kilometers of the structure. A last marketing slide that my marketing team would be very unhappy if I didn't put it here. So we believe that the true innovation comes through collaboration, so we're really happy we can all meet here, and I warmly welcome you to come to our stand and we can talk about how we can work together. Thank you.